Guys, it's getting super crazy out there. Generation Z is using this new technology called vector displacement, and quite frankly, we're going to be left behind if we do not adapt, evolve, and learn how to use vector displacement. So that's what I'm going to be teaching you today. We don't want to fall prey to those Gen Z. They're just going to be going light years above us. Okay, what are we talking about today? Vector displacement. So you can see I have a sphere. This is a scene I made. There's a sphere and a node network, and we don't really know what any of this does yet, but I'm going to explain it. But all we know is that most of this, except for the diffuse BSDF, ends up going into something called a vector displacement node, and when I crank that up to 1, for some reason we get a hat. So welcome to vector displacement, turning spheres into hats. That's what we're going to be doing today. Basically what vector displacement is, for those of you who don't know, and I'm pretty new to this as well, is it's kind of like displacement mapping, where you can take a mesh and then deform it along the normal. So you displace it, usually upwards, but generally along the normal. It's like that, but it's vector displacement, meaning it's not just along the normal, but it's in any direction you want. So the kids out there are making models out of spheres for some reason. Is this practical? No, but different applications of this are practical. So if you know how to make a hat, you'll know how to do anything. So we're going to go over how to turn a sphere into a hat, I guess, and just so we can visualize what's going on here just a bit better, I'm going to remove my subsurface and view the wireframe. What's happening here, and I'll make this a smooth transition, is we have a UV sphere. This is just the standard UV sphere, and then we're slowly deforming this thing into a hat. And all these nodes back here are basically the math equation that define how we go from sphere to hat. And how do we generate these equations? I don't know. We'll figure it out. Let's start up a new scene. Let me show you how to do it. This isn't going to be like an introduction to vector displacement, like a thorough thing. This is just going to be an example project for maybe your first time using vector displacement. We'll see how it goes. So, new scene, Blender 2.8, 83. I ditched 2.9. It was too buggy for now. What we're going to do is we're going to replace our cube with a UV sphere, although you can also do this with a rounded cube. Doesn't matter. Anything spherical is fine. Okay, we have our sphere. We're going to switch over to cycles, which is necessary for displacement and vector displacement mapping. And then, we don't need to change any more settings here. So that's the setup. Go to shading, create a material. We're going to call this VDM for vector displacement map, even though we're not, making a vector displacement map. We're just doing vector displacement. Last thing you need to set up, by the way, before we're good to go, is make sure to go to your material settings for whatever material you made, and make sure that displacement isn't on bump only, but displacement only, or displacement and bump. Otherwise, there's going to be no deformation, right? I'm going to go with displacement and bump, even though displacement only would be fine. So there we go. Okay, boys, how do we go from a sphere to a hat? Well, the first thing you need to do is you have to add in a vector. Did this sentence even make sense? Add in a vector displacement node and connect it to the displacement socket. And we're going to be using object space, which you're thinking, okay, what do these mean? Basically, the way you want to think about this is tangent space is very useful, but very hard to calculate. So it's hard to use, but it's useful. So we're just going to kind of brush that aside. And instead, we're going to use either object or world space, which basically say we put in a vector and the coordinates are just going to go to there. No complicated tangent space, no tangent by vector stuff, just object space, okay? So set that up. So currently what we have is, if we just put in a vector, so again, vector displacement, you can pick a vector for how you want to displace it. We're able to actually manipulate this. So right now we're just, putting a combine XYZ node in here, meaning we're basically displacing all the coordinates, every single vertex, we're shifting over by this vector, which just kind of looks like translation. You could also do scaling, whatever, and then we're going to talk about that. So the first question is, how do we go from sphere to hat? Well, you want to take it step by step. I don't know the equation, but we can construct it. So think about it like this. We're going to start off with a sphere. We can turn it into a cylinder. This is a pretty simple equation. So sphere to cylinder. Then we're going to squash it. So it kind of looks like a DVD or something, a disc or frisbee. So sphere to cylinder to frisbee. We're then going to curve it so it looks like a Pringle. And then we're just going to add the top part of the hat. Basically, we're going step by step. So part one, how do we turn this into a cylinder? Well, I'm going to use texture coordinates, specifically object coordinates, since this gives us, coordinates of every vertex on the mesh. with the origin at the center, which is very convenient. And the first thing is, how do we turn this into a cylinder? Well, what I'm going to do is I'm going to do a separate and combine, which effectively does nothing if we just combine all these x to x, y to y, and z to z. This effectively does nothing. We're just separating the vector and combining it. But if we want to turn this into a cylinder, on the z-axis, you might think about what that looks like. Well, really all it is it's taking the top hemisphere and flattening it, so it doesn't have curvature, but it's a flat top like a cylinder, and then same for the bottom. So basically we're saying any z coordinate that's positive above the floor, so top hemisphere, flatten it up to like 1, up to 2, up to whatever height, and then for negative values, bring it down and flatten it. Well, that means we need to manipulate the z coordinate. So again, we're making a cylinder. And basically what we just described is the math operation of, where is it? It's sine. And what sine does is it says if you have a positive number, output 1. And if you have a negative number, either output 0 or negative 1. I can't remember. But either way, we're taking top hemisphere, mapping it to a height, bottom hemisphere, mapping it to a different height. Okay, so you might think that this will work. So let's try it. We put it in our vector displacement. And you see that it's close. It kind of gives us a capsule. So kind of does what we want it to, but it's not really working. Plus, it's getting bigger for some reason instead of just flattening the hemispheres. The reason for this, and this is actually a very important point, so important that I need to save. This is a very important point. Vector displacement takes your coordinates and displaces it by some vector, meaning you already have some coordinate of where the vertex is, and then you're just adding something to it, some vector. But what we're doing here with this sine, this little math expression, is we're giving the coordinates for the cylinder. So we don't want to take an object and displace it into a cylinder because what I'm trying to say is we already have the coordinates figured out. We don't need to add in the original of the sphere. So we just need the transformation, not the original coordinates. So in other words, if we only want displacement and not the original coordinates, what we need to do is vector math, subtract. We're going to subtract away what vector? The original coordinates of our sphere. Boom. Cylinder. So again, we have a sphere. We gave it some math expression to, turn it into a cylinder, but that's just a displacement. It still keeps the original info, which is kind of redundant, so we subtract and get rid of it. Okay, so what does this look like in slow motion? Well, it just flattens the top, flattens the bottom. Pretty obvious, or pretty easy, rather. Okay, and we can view this. The normals are going to be a bit weird for now. Just ignore it. Okay, so we've made a cylinder. Next step I said is to flatten it into a disk. In other words, take your z-coordinate and kind of scale it down. So let's think about how to do that. Well, clearly we need to do some manipulation here before we subtract away the object coordinates. That's kind of like the last step. So what I'm going to do is I'm going to add another vector math node. And think about it, if we're scaling, your first guess might be to use like a scale, but this is kind of uniform, so just makes our cylinder bigger and smaller. We want that, but only on the z-axis. So I think there's a couple ways. I'm going to go with multiply, which gives us control of x, y, and z, so I'm multiplying them by 1, which means do nothing. But if we only change z, then we're effectively like extruding or changing the z scale of our cylinder. So I'm just going to make this pretty thin. Something like this. So again, we have a sphere, we turn it into a cylinder, and we also flatten it. Boom. Okay, next step, and this is kind of like the nice creative step. How do we turn this into a Pringle, into a saddle? Like the brim of the hat is kind of curved in like two different directions. So one way it's going like this, the other way it's like concave down, concave up, whatever. Effectively, the way we do this is what we want to do is we want to add another vector. And remember, adding just kind of means translate everything because we're adding the same vector to every vertex. So we're translating by the same thing everywhere. So we can displace our cylinder, but we want to displace it by different amounts depending on the vertex. And specifically, we want a nice curvature. That's the idea. So what we can do is we've already separated our object coordinates. So let's examine the x-axis. So what we can do is we can say as you progress along the x-axis, kind of do a nice curve instead of bringing it up everywhere, right? So let's actually do that. You can do that with probably RGB curves is the smartest way to do that. That's what I've done before. So we're just going to take x and plug it in here. So we took object coordinates, x value, and put it in here. And then the idea is what we want to do is, again, we're doing a vector math addition here to add curvature. So I want to be able to control x, y, and z separately. That's why I'm putting this here. And we can add it to the z. So right now what you're seeing is we had the circle, the cylinder, the disk, and now we're kind of adding, kind of like normal displacement almost, kind of, not really. We're adding vertically on the z by this amount as we go across the x-axis. So you can see what that looks like. And we have complete control over this, of course. So first thing we might want to consider is that since we're using object coordinates, it goes from -1 to 1 for the x-axis since it's centered at the middle. I want it to go from 1 to 0 because that's what RGB curves expects. I'm just going to do this with a quick map range node. So instead of 0 to 1 to 0 to 1, -1 to 1 to 0 to 1. So now it goes from here to here instead of, from here to here. So we're just kind of remapping everything. So now let's look at what this looks like. Okay. And it's actually pretty intuitive what we're doing here at this point. You're literally just drawing what it looks like. So you can see we made this curve and it does that curve over there. So if we want a nice curvature, we can have both 0 and 1, like pretty much uniform. So all of these are kind of being translated up just a bit by this elevation. And then in the middle, we just kind of dip it down. So you see we're getting a nice saddle there. So again, we're adding on the z-axis, given by a function as we travel along the x-axis. I know vector displacement is confusing. For those of you who are like, oh, I thought nodes didn't have math involved. They do. Surprise. Okay. So now we need a saddle. So it curves up like this, but we want it to curve down along the y-axis, which means basically do the same thing. So I'm just going to duplicate this time use the y-coordinate. So now we're looking at it this way. So we've already curved it going along the x-axis. Now we want to curve it along the y-axis. So again, we had -1 to 1, which I mapped to 0 to 1. And then I'm going to connect this to its own RGB curves. So right now what we could do, and again, even though we're now going instead of x-axis, y-axis, we still want to displace upwards on z. So we'd still plug it into the same socket here. Let me just do that. Math, addition, add these. I don't know what my sentence was. Basically, what I was trying to say is right now we have the exact same RGB curves, which means as you look at it from the x-axis, it's going to curve like this. And same for the y-axis, which means it should make some kind of bowl. It'd be easier to see with diffuse BSDF. Kind of looks like a bowl. We want one side concave up, one side concave down. So what I'm going to do is I'm just going to reverse this. So this goes up and these go down. So you can see from this view, this hill is basically being shown exactly here because we're looking along the y-axis. So we should now have a nice saddle. Curvature one way, different curvature another. Okay, so let's see what this looks like. I always like doing this. Look at that. So you can see how we're not really making the equation for the hat in one go. We're taking it step by step by step, doing all the work here and then finally connecting it to the vector displacement. Of course, we subtract object coordinates first, but that's the idea. So finally, what we need to do is take the center and bring it up. This is where the head is, just bring it up. And basically that just means define a circle, and for that circle, displace upwards. That means add to the z-axis. That's all there is to it. Okay, so how do we define the circle? Well, probably your first guess, if you've watched some of my videos, is to use length for object coordinates, which kind of works. You might not be able to see this gradient because of, it's kind of faint in YouTube compression. Basically what it's doing is it's looking at the three-dimensional vector and outputting the length, giving it this kind of radial gradient from the center, which is kind of similar to a circle in the middle, but not really, because it's a three-dimensional thing instead of a two-dimensional thing. We just want a circle going outwards from the top view. So just imagine a circle kind of emitting outwards that doesn't actually have a z component, meaning all we need to do is kind of only consider x and y, not z. So what I'm going to do is I'm going to multiply this incoming vector by 1, 1, and 0, basically saying keep x, keep y, make z 0 everywhere. And now we have this nice radial fall off, not spherical, but radial. So before, after. Okay. And again, the idea here is this is yet another thing that we're going to add to our z displacement. So you can see now it makes like this weird, it took our saddle and just kind of punched inwards. which isn't what we want, but you can see, you know, the idea is correct. So what do we need to do to fix this? Well, basically, let me just get rid of this for now, since we're not there yet. We do have the radial gradient, but we don't want it to be like black in the middle and white outwards. In fact, what we want is full displacement in the middle, and then once it gets big enough, like the size of the head, there's just no displacement. I'm just going to do this with a color ramp to get a nice little bit of a fall off. So first of all, what I said is we want displacement in the middle, right? So before, what we had is the center was kind of held still and everything else was brought upwards. We want to reverse this. I'm just going to flip the handles like this. So now you see we kind of have the reverse thing, which will kind of displace the middle upwards, but we only want kind of the middle of this. So I'm just going to pick an area, something like this, right? So you can see what I mean. It's going to pick this area and displace it upwards. And since it already has that saddle curvature, if we displace it upwards, it's going to have that saddle curvature on the top, which you can get rid of, but I actually like it. Okay. And notice that it does it on the bottom and the top, which in this case is a good thing. So let's see what this looks like. We're going to add our color ramp, which you can see is kind of doing the right thing. So again, really what it's doing is it's taking the center and just bringing it upwards, but keeping that curvature on the top. And again, the nice thing about this is we can control, it's all procedural. And in fact, we want these two handles pretty close together, so it's more of a sharp upwards instead of like a diagonal. Unless you're going for that fedora look, you know, that's up to you. And the reason I don't use something like a constant, so it just goes immediately, is it's kind of like too sharp. We want a bit of a fall off so there can be some geometry there. And let's actually visualize what this looks like. I had this before. If we use a wireframe node, we can actually see the geometry. So what I was saying is that with a constant, it just goes straight up. There's only, I mean, these are triangles, but imagine they were quads. There's only one strip of quads going around, which might be what you want, but I want a bit of a fall off. Not much, so we can have them really close. Right now it's effectively the same, but when we add in more geometry with like subdivisions, we're gonna eventually, if we have enough, now you see we have multiple quads in this area. But that's the idea. And yeah, I guess technically we did finish. And notice that since that radial thing, radial mask we made was at the top and bottom, it's actually like a physically correct hat. You could actually put your head inside of it. It doesn't just displace the top, but also the bottom. Okay, let's see what this looks like. So we have a sphere, and we slowly deform it into a hat. This is the weirdest Blender tutorial of all time. Needs to be done, though. And you might be wondering, why does this look so bad? So first of all, make sure you have shade smooth. Second of all, make sure you have good lighting so you don't get weird shadows. And this is the kind of thing that does happen with vector displacement maps. You get weird lighting, but I'll show you how to fix it. Okay, so if you've already done shade smooth and made like even lighting with like an HDRI or something, and you're still seeing this kind of weird normal stuff, the reason for this is it doesn't actually have enough geometry to calculate good normals. So right now, this is what the normals look like. You can see they're very broken. Same with the true normals, kind of. But we're interested in normals. They're kind of broken. But to fix this, if we just add in more and more geometry, you can see that it slowly refines. It does take a bit of time, but it's doing an okay job. So now if we view this, you can see it's a bit smoother. There is a bit of a weird shading error right here. And you can see that's reflected into normal. It kind of immediately gets cut off. So again, you just want more and more divisions. And really, instead of just making this number higher, what I would recommend is enabling experimental mode and adding in a subsurf with adaptive, which will kind of pick a amount of subdivision depending on how close we are to the object, and like pixel slicing and all this. So let's see what this looks like. So now it should look much smoother. Not perfect, of course, because the more geometry, the better. You can actually increase it just in viewport too. Of course, this will look better on render. But you can see this already, you know, it works. And because it's a nice, I mean, again, there's no point in this, but because it is procedural, we can always go back and control things. So we already talked about the hat top thing. So now we have a nice slanted thing. If we control the color ramp, we can also control the thickness of it, which was, remember, we scaled the z-axis only. So here we can have a super thick hat, should be twice as thick. and we can have a hat that is half as thick. It's taking a long time to calculate because I'm recording at the same time. We can also control the curvature at any point. We can also do some like weird stuff. Just add another handle here and it's gonna make weird hats. Maybe you could do something out of that. I don't know. Basically, the rest of this is just surface stuff. This is just how you get the shape of it using a vector displacement. You know, the rest of it, you could be like, oh, I want a, I don't know. I want like a noisy hat to give it like nice texture. You can do all that. This is just surface stuff. Make sure that when you do this, you're going to see some stretching. And this is a tip I got from a JC, if you're familiar. Don't use generated coordinates, use object coordinates. Those don't distort. And then you're going to get a nice, even, uniform distribution everywhere. So there you go. I mean, I don't know if you wanted to know how to make a hat out of a sphere, but you can now. You could also do it out of a rounded cube, like I said. Yeah, you know, that. I don't know what to tell you. So there you go. That's your first introduction to vector displacement. At some point, I might do a formal series on this, starting from the beginning. I don't know. Seems like a lot of work, though. Anyways, if you enjoyed this free tutorial, the best way you can support me is via Patreon, and you could either do that as a donation if you're super nice, but if instead you want something out of it, there are benefits. You have exclusive tutorials, behind-the-scenes access, Discord, tutorial files, depending on the tier you get. But really, this is the only way I can do this full-time. So. Anyways, I hope you enjoyed. You now know how to make a hat. Enjoy vector displacement. It's quite a trip. I mean, honestly, it wasn't that many nodes to go from sphere to hat. You might think that it'd be hundreds. No, it's like 20. So, yeah.